Today's video is about solving addition and subtraction equations using the algebraic method. So our goal is to use the property of equality and the algebraic method to solve addition and subtraction equations. One of the problems we run into with students looking at equations is they know how to figure them out because the numbers we start with when we first learn this are easy to use numbers. So a couple of quick examples might be, x plus 5 equals 9. And students look at that problem and they immediately know, I know it's 4. And I'll say, well, why? And you're like, well, because 4 plus 5 is 9. And so what we're going to be going through is a process that we're going to follow that will help you to solve them all the time, not just when they're easy like this. And so you'll need to be patient with me because we will be doing what seems like extra work to prove our answers, but what we're really doing is we're laying a foundation that will work as you move on in 7th, 8th, 9th grade in solving equations. So first thing we want to talk about is what the solution means. When you're asked to find the solution of an equation, we're basically looking for a value that makes the equation true. So when I look at this equation, x plus 5 equals 9, which we just had done, I might say, well, maybe 3 is the solution. Is 3 the solution? Is x equal to 3? Well, I can plug a 3 in here. And 3 plus 5, that doesn't equal 9. 3 plus 5 equals 8. So x does not equal 3. That's what this symbol right here means. Is not equal to. X is not equal to 3. Well, I might say, well, is x equal to 4? And I know we all know that it does. But if we plug in that value, 4 plus 5, well, that does equal 9. So yeah, that does equal 9. And if we were to again try x equals 5, we substitute that value in, 5 plus 5 does not equal 9. So no, x does not equal 5. So x does not equal 3, x does not equal 5, but it does indeed equal 4. So that's the answer we're looking for there. So what you'll be asked to do a lot of the time is you'll be given an equation and you'll be given a potential solution, and it's your job to decide whether that solution is a solution to this particular equation. So when it says x plus 15 equals 17, you're basically just going to plug that 3 in place of that x. And you'll say to yourself, is 3 plus 15, does that equal 17? And you know it doesn't. 3 plus 15 equals 18. So the answer here is no. 3 is not a solution to this equation. X does not equal 3. Now here it says 12 minus m equals 8. We're going to plug in m equals 4. So we're going to replace this m with a 4. And when we look at this example, sure enough, 12 minus 4 does equal 8. So yes, this is a solution to our equation. And finally, now we've got a multiplication equation. 42 is equal to 6y. We're going to plug that y in with the 7. So this means 6 times y when you've got that coefficient in front of the variable. And sure enough, again, 6 times 7 does equal 42. So yes, this is a solution. So really, when you're asked to tell whether the given value is a solution to the equation, you really only need to write yes or no. But ideally, you'll do the same thing I did and just prove your answer. Justify why you know that it doesn't work or why you know that it does work. You're not asked to give the actual value. You're just asked to tell whether the given value is indeed a solution or not. Now, let's get to our goal again, which is to use the property of equality and the algebraic method to solve addition and subtraction equations. So if we're going to do that, we need to know what the property of equality is. We're going to start with the addition property of equality. The addition property of equality states if you add the same number to both sides of the equation, the two sides remain equal. So in our initial equation, m minus 5 equals 12. If I add 5 to both sides of that equation, it changes it to m is equal to 17. We have to understand that by adding 5 to both sides, our balance scale is still balanced. If I add the same amount to both sides of a seesaw, it still balances the same way it's currently balanced. So that concept is what we're going to be using, and I'll demonstrate that in a moment. And this is merely the way we show the work here. So the subtraction property of equality works the same way. If you subtract the same number from both sides of an equation, the two sides remain equal. I'd like to give you a visual aid for this. So here's my version of a balance scale, and we'll use a couple of these little blocks to help us to prove this answer. I have some blocks here. And so I'm just going to put a couple of blocks in place here, and you can see very clearly 2 blocks is equal to 2 blocks. That's definitely a true statement. Now, when I take away a block, it's not balanced. Well, that's because I took one away. But if I take one away from both sides, it would remain balanced. And that's the idea. And in the same concept, I could add one to each side, and it would remain balanced. So what we want to understand is when we talk about the property of equality, again, the addition property of equality, which states if you add the same number to both sides of an equation, the 2 sides remain equal. So here we go. If I add 1 to both sides, it's still going to balance out. And on the same end, with my subtraction property of equality, if I subtract the same number from both sides of an equation, the 2 sides remain equal. So if I take 1 away from each, it would still balance. And obviously, you've got to kind of imagine that on your own to see how that works. But that is the guidelines we're going with, just to understand a basic understanding of what we mean by the property of equality. Now, if we're going to go ahead and meet this objective of using the property of equality and the algebraic method to solve the addition and subtraction equations, we're going to be working with one-step equations today, which is it's funny because a one-step equation actually has 3 steps, the way I'm going to show you. And the idea of it is that first you need to get the variable by itself. We use the word isolate the variable. The phrase isolate the variable means to make the variable by itself. If you think of the word isolate, sometimes your parents might send you to your room. That's to keep you isolated from everybody else, okay? They want you on your own because you're either aggravating somebody or maybe they're getting aggravated with you. So they want you by yourself. They don't want you with anybody else. The way we isolate variables is we use the inverse operation. Then we use what we know about the property of equality to balance everything out. Because if we're going to take something off of one side, we need to take it off the other to make that work. And then finally, just like we did in the beginning, we're going to check our answer by plugging it in the place of that variable to see if it's true. So I'm going to leave this little note up here, and we'll take a look at these 2 examples. These are both addition equations. So if I'm going to solve these, the property of equality I'll use is the subtraction property of equality. So first thing I'm going to do is I'm going to isolate the variable. Right now, I want that x all by itself. To do that, I need to get rid of this plus 5. We know the inverse of adding 5 is to subtract 5. So really this is x plus 5 minus 5. Since we're adding 5 and subtracting 5, we're just going to cross it off like it never happened, and we're left with x. Because of the subtraction property of equality, we know that if you subtract the same amount from both sides of the equation stays true or stays balanced. So since I subtracted 5 here, I'm also going to subtract 5 here. All right, so now I'm going to use my property of equality. That's why it's balanced out. And when I subtract 16 minus 5, it leaves me with 11. So the answer I've come with, the solution, is x equals 11. Now if I plug that in, 11 plus 5 does equal 16. So that is checked. And for sure, that's a correct solution. X equals 11. Now when I look at this equation, the same thing. I'm going to isolate my variable by doing the inverse operation. So the opposite of adding 3 is to simply subtract 3. And again, b plus 3 minus 3 is the same thing as just b. So I'm just going to cross that all out and leave myself with just b. Now, the subtraction property of equality says that I can subtract the same amount on both sides of the equation and it'll still stay true or stay equal. And 10 minus 3 is 7. And that tells me my solution is b equals 7. Now, to double check, I'm going to plug in the 7 for my b, and 7 plus 3 does equal 10. And so this is a solution to this equation, b equals 7. That's a correct answer. So I'm going to try a couple more of these, just going a little faster, maybe a couple larger numbers. So we're isolating our variable. We're going to do the inverse operation. We're going to subtract 8. That leaves me with just c. And then over here, using my property of equality, I'm going to subtract 8 as well. Keep everything balanced and equal. 20 minus 8 is 12. And let's go ahead and check my answer. 12 plus 8. It does equal 20. And so that's a true statement. Now, obviously, if you subtract wrong and then you're not really taking this last statement seriously and you're just plugging it in without thinking, then this check is not going to help you. So sometimes, especially for those of you with larger numbers, you need to show your work in both your subtraction and your addition if you're not sure if we're dealing with larger numbers. D plus 4, we're going to subtract 4 to isolate our variable. That leaves us with D. and then we're going to subtract 4 over here, leaving us with 14. D equals 14 is our solution. Let's double check that answer and plug that in. 14 plus 4 equals 18, and that's a true statement. So there we go. We've checked all our work. So let's take a look at some subtraction equations, and the inverse of subtraction is addition. So I'm not going to subtract 3 from minus 3. I'm going to add 3. And a lot of people have trouble with this, but we've talked about integers and their opposites. So you kind of have the idea is if I've got a number and I subtract 3 and then I add 3, I'm still back to that number. So that same cancellation would occur by doing that inverse operation. Now, in this case, I added 3. Now, according to the property of equality, if I add the same amount to both sides of my equation remains true or equal. So I'm going to go ahead and add 5 plus 3 and get 8. And I believe the answer to the solution to this equation is n equals 8. The way I can check is I can subtract 8 minus 3, and it does equal 5. So that's a true statement. N does equal 8. When I look at this example, g minus 5 equals 11. My inverse operation will be to add 5, and that's going to leave me with just g. Because I added 5 here, I'm going to add 5 over here to keep my equation balanced. 11 plus 5 is 16, and g does equal 16. Let's plug that in and see. 16 minus 5 equals 11. Let me show you how you might check that work. You might just actually write that out, and sure enough, that is 11. And so that is a true statement. You checked it, and you're correct. So let's do 2 more examples like this. Again, slightly larger numbers. And we're going to isolate our variable by doing the inverse operation. So that's and I'm going to add 10, and that's going to leave us with just y. And then because we added 10 on this side, we're going to add 10 over here. And that's going to leave us with 52. And so x equals 52. And we can plug that in and do 52 minus 10. Again, that's one you could probably do in your head and know that that's a true statement. At y equals 52 is correct. M minus 6 equals 12. We're going to go ahead and add 6 to isolate our variable, leaving us with m. And we'll add 6 over here, giving us 18. And we believe m equals 18 is the solution. If I plug that in, 18 minus 6 does equal 12, which means that we were correct with m equals 18. Again, my suggestion is we're going to show this work every time because it's going to get us into good habits when we start dealing with larger numbers and multiple step equations. So this process, this one-step equation, 3 steps that we're going to follow, we want to see that work every time you solve an equation, even if it's a simple one. Now, what we're going to do now is we're going to actually solve a word problem by combining our skill from the previous unit, where we're going to try to write an equation that matches the story, and then we can solve the equation to finish it off. So it says right here that the cost of a movie rental is $3. And this is $2 more than it was last week, so I guess the price is increased. No, I'm sorry. Yeah, the price is increased. So we got to figure out what this all means. So we're going to write and solve an equation to solve this. And our goal actually will be to write a statement that shows this. And what I'm thinking to myself is I can kind of write this in simpler terms. I'm going to really basically say that $3 is $2 more than, and I'll use the variable x, because x is what it cost before. So $3 is $2 more than x. So if I use that statement, I know is means equals. So my equation is 3 is equal to 2 more than x. Now we all know that more than means adding, but it's also a phrase that requires us to switch our order. So our expression would be x plus 2. So my total equation is 3 is equal to x plus 2. Now that I've got that equation, let's use our format here and solve this. Okay, so we're going to go ahead and we're going to isolate the variable by doing the inverse. The opposite of adding 2 is to subtract 2. That leaves me with x. And then I'm going to subtract 2 on the other side using my property of equality, which tells me 1 is equal to x. I'm going to plug my answer in. Is it true that 3 is equal to 1 plus 2? Sure it is. So the correct answer of x is equal to 1 or 1 is equal to x is a correct solution. So I've done everything I was asked to do. I wrote and solved an equation to find the cost of the movie rental last week. It turns out the movie rentals must have been on sale last week for only $1. Thanks a lot for sticking around till the end.